write this. Yes, you're writing this down there. Your notes. That's a silly question, girlfriend. Alright, so we're simplifying expressions with the product property. That's going to be the first thing we're doing. So basically what you're going to do is you're going to break down this radical into the most simplified terms. This is a square root, okay? With a square root, that means you have to have two of a number or two of the same variable in order to pull one out. So, do you know what the square root of 32 is? No, there's not a perfect square for that. 36 would be our 6, and 25 would be 5. But 32 does not have a perfect square root. So we've got to break down that radical using the factor tree. Okay, so whenever you're using your factor tree, you always want to start off with 2. That's what I always do just to make sure that we keep everything together. Is 32 divisible by 2?
Yes.
What times 2 will give you 32? 16. Is 16 divisible by 2?
Yes.
2 times what will give you 16?
8.
Is 8 divisible by 2?
Yes.
2 times what?
4.
And is 4 divisible by 2?
Yes.
2 times what?
2.
Okay. So now all of this goes into your sock. What that means is that 2 times 2 times 2 times 2 times 2 gives you 32, and you're going to replace that 32 with all of that. So I have 2 times 2 times 2 times 2 times 2, and then I have x to the power 8. So how, okay, we'll hang on. So we'll just keep x to the power 8. Okay. In order to come out of a square root, you have to have 2 of something. Okay? So I have 2 2's. I have 2 2's. The same concept goes with our x to the power 8, so I just want to do one more step right here. Could have done this up there, but I didn't. I want more space. I'm going to do x to the power 2 because I need 2 of them, right? And x squared is x times x, so that's 2 of them, correct? I have another x squared, so how many x's do I have all together right now? 4. So I do another x squared, which means I have how many x's?
2.
And I have one more x squared, which now gives me how many?
8.
So x to the power 8. So where you have 2 of something, we're going to bring it out. I have 2 2's right here. I have 2 2's right here. I have 2 2's right here. And I have 2 2's right here. For every 2, you can bring out 1. So I have 2 2's. We will bring out 1. This is multiplying. I have 2 2's. So I'm going to bring out 1. I have 2 x's. So I bring out 1. I have 2 x's. So I bring out 1. 2 x's. So I bring out 1. And 2 x's. So I bring out 1. What are you left with inside of the radical? 1 2. That is it. But are you ever going to see it written like this? No. We need to fully simplify. What is 2 times 2?
4.
And what is x times x times x times x?
4x.
Not 4x. That's adding x to the 4th power. Perfect. Then you have your square root 2. This is fully simplified version. right? You're good. They're not always going to give you square roots though. They can give you cube roots, they can give you fourth roots, they can give you fifth roots, or so on, okay? So it does get a little bit more difficult. All that number tells you is how many you have to have in order to bring one out. So we're going to simplify this. I have 16. Is 16 divisible by 2? 2 times what will give you 16? Is that divisible by 2?
Yeah.
Times what?
4.
And 2 times
2.
2. So this is what goes in your sock. We are replacing 16 with those 4 2's. So this is the 4th root. Don't forget to write that 4 because it is important. 16 is now replaced with 2 times 2 times 2 times 2. Then we have times a to the power. We need 4, so I'm just going to put a to the power 4. Another a to the power 4 will give you how many?
8.
Another a to the power 4 will give you how many?
12.
Another a to the power 4.
16.
Another a to the power 4.
20.
Another a to the power 4.
24.
That's what we needed, right? You needed 24. Gonna erase this. Then I have my b to the power 13. We need to take 4 out. So I have b to the power 4. Another b to the power 4 will give you 8. Another b to the power 4 will give you 12. How many do I need? I need one more. So I'm going to put times b. You need 4 of something to bring 1 out. So I have 4 2's. Because this 4th root tells you that you need 4. The radical, the number that is on the outside of that radical tells you how many you have to have. The square root has an imaginary 2 there, okay? So I'm going to take out 1, 2. I have a to the power 4, so I bring out 1a. A to the power 4, 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 bring out 1a. B to the power 4, bring out 1b. B to the power 4, bring out 1b. B to the power 4, bring out 1b. And you are left with the 4th root of what is left, ab. But now we have to simplify this because you will never see it written like this. We have 2. How many a's do you have?
6.
6. So it's a to the power 6. Then I have 3 b's. So that is b cubed. And you have 4th root b. Now, is it necessary to write out all of these steps? No, not really. I don't write out the a's and the b's. How I do it, and this is completely up to you, I'm still going to be working it out just for some people because it does help them to see it visually. But for me, I do the factor tree for the numbers, but that's the only thing I do it for. For the letters, I have a to the power 24. I know that I'm going to need 4 in order to bring 1 out. So what do? I divide the a to the power 24 by 4, and it gives me a to the power 6. Okay? For the b to the power 13, you do the same thing. However, you say 13 divided by 4. Okay, it's going to give me 3 point something. Well, why? 4 times 3, b cubed, will give you 12 with how many left over? 1. See what I'm saying? But if you need to write it all out, do so. But I bypass that step. The only part that I actually do write out is the number part. Because sometimes that can be a little tricky. Okay? So this is your fully simplified version. So So another one, this is a square root because there's no number, there's an imaginary 2 there telling you to take the 2 out. You do your factor tree of 12. So 2 times 6 will give you 12, and 2 times 3 will give you 6. You place this in your sock. 2 times 2 times 3 is going to replace that 12. So I have 2 times 2 times 3. Do you want to try doing that shortcut way, or do you want me to write it down? Try it? Okay. So we're going to keep c to the power 6, and we've got our d cubed.
Why you did 2 times 2 times, oh, never mind.
2 times 2 is 4, 4 times 3 is 12. So it's the same exact thing, just broken down. The whole point of a factor tree is to get it down to all prime numbers. So you want to make sure that you are down to all completely prime numbers. I have 2 2's in common, so I'm going to bring 1 out. Then I look at my letters. So I know that I have 6 C's. I need 2 to bring out 1. So I'm going to say c to the power 6. 6 divided by 2 is what?
3.
So c cubed is what's going to come out. Then I have d cubed. How many times will 2 go into 3? Once. So you're going to take out 1d, but the part that you have to remember is that, okay, I've got my square root, what was left over, a 3, all of my c's were gone, but I only took out 1d, so how many d's were left over?
2.
Not 2, because remember, you have to have 2 to bring out 1. So you have to take 2 away from that, giving you 1. Does that make sense? Did somebody say no? Okay. So then that tells me that, and that's fine. That just means that I don't want to skip that step. We want to write that out. That way you can see. So you have, I need 2 to bring out 1. So c squared times another c squared is c to the power 4 times another c squared is c to the power 6. Then we have our d's. D squared, how many more d's do I need? 1. You can take out, you have to have 2 to bring out 1. So I have 2 of all of these things.
3.
So I bring out the 2. I bring out a c, and a c. 1, 2, 3. I also bring out a d. It's a square root. What am I left with? A 3 and a d. So this is 2c cubed, because I have 1, 2, 3 c's. And then d with square root 3d left over. Okay? Make sense?
Yes.
Okay. Do you guys want to try this one on your own?
Yeah.
Okay, so try this one on your own and see what we get. 27, it's not divisible by 2, so you move on to the next prime number, which is 3. 3 times 9 will give you 27, and then 3 times 3 will give you 9. This is what's going to replace that 27. The cube root tells you have to have 3 of something to bring 1 out. So I have the cube root of 3 times 3 times 3. Then I have y to the power of 3. Another y to the power of 3 gives me 6y's. Another y to the power of 3 will give me 9y's. Another y to the power of 3 will give me 12y's. So then I have z to the power of 3,
I got a question.
z to the power of 3, and another z. The reason why we took out cube for this one is because I need 3 of something to bring 1 out.
So I did that wrong. I put 4.
Okay, so the last one we did 4 because we needed, it was a 4th root. This number tells you how many you have to take out in order to simplify. So if it's cube root, that means you have to have 3 to take out 1. If it's 4th root, you have to have 4 to bring out 1. Square root, 2 to bring out 1. If it's the 8th root, you have to have 8 to bring out 1. Does that make sense?
Yeah.
Okay. So we have 3 3's. There's 3 y's, there's 3 y's, there's 3 y's, there's 3 y's, 3 z's, 3 z's. And just so I can make sure we're clear, the reason why that's 3 y's is because technically that is y times y times y. Just to make sure we're clear. So I have 1 3 that I'm going to bring out, a y that I will 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 bring out, a z I will bring out, another z I will bring out, and I will write the cube root. Don't just put a square root and think you're good. It is a cube root. There is a huge difference. So make sure you put that and you don't forget. And what are we left with? A z.
I have a question.
Yes,
If
ma'am.
you skip that step that you did with the y solutions and you just write that step right there that you just did, would it be wrong?
If you're gonna skip this step,
I got it right though. I had got it right, but I had erased it because I thought that it was wrong.
gotcha. Generally, you're not gonna be able to get this step without writing this step.
I did
If anything, you're gonna go from this to this step that we're about to do, which is 3 y to the power of 4 z squared cube root
3z.
z. Because I could have went straight from this to this, because I know the cube root of 27 by heart. That's the easy one. It's 3. Y to the power 12, I do 12 divided by 3 gives you y to the power 4. Z to the power 7, how many times will 3 go into 7?
2.
Twice. 2 times 3 gives you what? 6. So 6 of them are gone, how many was I left with? 1. So I go from this to this, and if you can do that, I'm cool with that.
Okay.
I don't need all of this additional work. This additional work is for if you can't, your mind doesn't work that way, because some people are like that. Their mind doesn't work that way and they can't go from this down to that. And that's fine. Show it. But if you can, I get that. Alright. Okay, so we just did product property. Everything was multiplication. This is a little bit different. This is the quotient property. Alright? So if you have a fraction within a radical, you are always going to split it up, and you are going to have a radical on the top and a radical on the bottom. What does that mean? That means you are going to transition from this and turn it into square root x to the power 6 over square root y to the power 7. are not allowed to have a square root on the bottom in order to be in simplified version. So you figure out what you can multiply this equation by in order to get rid of the square root. Okay? So listen, the square root ones are the easy ones. Why? Because the easy part about this is that I know that I want to get rid of this square root and I need to have 2 of something in order to bring 1 out, right? So right now, I have 1 y to the power of 7. Do you see that?
Yeah.
If you multiply this equation on the bottom, or this expression on the bottom, by another y to the power of 7, now you have 2, right? I have a y to the power of 7 here, times another y to the power of 7. Do you see that? Okay. But we don't want to change the expression at all, so you want to multiply it by 1. How do you do that? Anything over that same number is going to give you 1, so you want to multiply it by the square root of y to the power of 7 over the square root of y to the power of 7. That is technically like multiplying it by 1. Okay? When this happens, the shortcut to knowing is that the square root and the square root are going to cancel out, leaving you with a y to the power of 7 on the bottom. But the actual math behind it is that when you have square root y to the power of 7 times another square root y to the power of 7, when you are involving radicals and multiplication, I always teach it this way. It's inside times inside, outside times outside. So this is actually radical y to the power of 7 times y to the power of 7, which gives you what? Y to the power 14. Power times a power, so we add. Do you guys remember those rules from Math 1? Okay. So square root y to the power of 14. This is a square root. How many does that say that you have to have in order to bring out 1?
2.
2. What is 14 divided by 2?
7.
Y to the power of 7. This is all the math that's actually going on behind it, but if you know that when you multiply by another square root cancel out, you're just multiplying by the power of 7, that's good for me. Okay? Have I lost anybody yet?
No.
Okay. So now, you do the same thing at the top. We've got the square root. Do you remember what I did for the bottom? What did I say was actually the math going on? Inside times inside, outside times outside, right? So that means you can take and you can conjoin both of those radicals. So this is going to turn into x to the power of 6, y to the power of 7. And we know how to simplify that radical, right?
Yes.
How are we going to do that? This is a square root, so that tells you you need 2 of something in order to bring 1 out. So what is 6 divided by 2?
3.
So an x cubed will come out. So x to the power of 3.
Where you get 2 from?
Because it's a square root, so that's an imaginary 2.
Wait,
Huh? The y7 is not going to go away. You are going to divide. So how many times will 2 go into 7?
3.
3 times. So I'm going to bring out a y cubed. So if it only goes into it 3 times, that means 2 times 3 is 6. So we took away 6 y's. So how many y's do we still have left?
1.
So you still have a square root y left. Then we have y to the power of 7 on the bottom. This is where most of you are going to want to stop. But you cannot do that. Why? Because remember from Math 1, our exponent rules. power over a power, so you subtract. Okay? Yep. Goes to happy, and you know what? I've got that song if you want it again.
Yes.
Okay. I'm gonna have to print it out. But I do have it, saved on my computer. So the easy way is saying I have 3 y's on the top. I've got 7 y's on the bottom. How many y's do they have in common? They've got 3 in common. So if I take away 3 y's, and I take away 3 y's, remember you have to do the same thing on the top and the bottom, what are you left with?
4.
X cubed is not going to change. Y to the power 0 is what you're going to be left with, and anything to the 0 powers is 1. That's another one of those exponent rules. Anything to the 0 power is 1. So we're not left with a y on top. We do, however, have square root y. That cannot simplify with your regular y. And this is over y to the power 4. Why can't the square root y simplify with this y? No. Because just like it's inside times inside and outside times outside, it's inside divided by inside and outside divided by outside. So on the outside of this radical, technically there's a 1. So it's like saying 1 divided by y to the power 4. And then square root y, what is technically the square root that could possibly be with that? No, not the square root of 2, we don't know what it is. Square root of 1. So it's like square root of y divided by square root of 1. So you can't do anything else with this. You cannot mix radicals and regular numbers that do not have a radical. Okay? Does that make sense? Are you sure?
No.
No? Okay. So this is why I said this is the hardest unit that you guys are going to learn. Okay? And it's not that this is a hard unit. Look, this is where you stop. Stop. You can't go any farther than this. The problem with this unit is there are a ton of rules. And if you don't know them, you're in trouble. Okay? So you have to know your exponent rules. You need to know them inside and out. I'll print off the song for you, and I'll actually leave that with my regular kids on Monday too, because they're going to need those, I'm sure. But those rules are going to come into play. And just remembering inside times inside, outside times outside. You can't mix radicals with regular numbers. Just remember that, okay? Let's do another example and see if it'll help you a little bit. I'm not going to move on to 4th root yet because it's a little bit different. So we're going to do another square root just to kind of get us adjusted to it. This is always everyone's least favorite.
Is there a way to skip all these steps like you did all of them?
Huh?
Is there any way to skip all the steps and close on property like you did all of them?
No. What you see is what you get for that one. I already did skip steps in that. So for this, you gotta split it up. So I have a to the power 6 over square root of b to the power 5. You cannot have a radical on the bottom. So we've got to figure out what will make the radical go away. We need to multiply it by something. I'm going to multiply it by the same thing that I already have on the bottom, which is square root b to the power 5. But what I have on the bottom, I have to multiply on the top too, because I technically want to multiply this by 1. And square root b to the power 5 over square root b to the power 5 will give you 1. On the bottom, your square roots are going to cancel out. What's up? You good? So on the bottom, your square roots are going to cancel out. And that's going to leave you with just a b to the power 5. And on the top, it's inside times inside, outside times outside. So you can combine these together because they are both a square root. Now, let me say this, if you have a square root and a cube root, they are not the same thing. You can't combine those. You can only combine them if they are the same radical. So square roots and square roots can go together, cube roots can go together, but you can't mix a square root and a fourth root, okay? So I have a to the power 6, b to the power 5. Now we simplify. It's a square root, so how many do I have to have in order to bring out 1? 2. So we have that imaginary 2 up there. A to the power 6. So 6 divided by 2 will give you what?
3.
Will there be any left over? No. So I can bring out an a to the power 3 on the top. What about b to the power 5? How many times will 2 go into 5? 2. So b squared can come out. 2 times 2 gives you 4. So 4 b's are gone. How many b's do you have left? 1. So we started off with 5. So I am left with a square root b. This is over b to the power 5. You do subtract. This is power over a power, so you subtract. How many b's do they have in common? 2. I have 2 b's on the top. I have 5 b's on the bottom, so they have 2 b's in common. If I take away 2 b's from both of them, I'm left with no b's on the top. So I have a cubed square root b over b cubed, because 5 minus 2 gives me the cube. You cannot simplify this anymore because you cannot mix a radical with a whole number or letter. Make sense?
Yes.
Okay. So we're going to go back to fourth root. Okay? This is where it gets a little bit tricky, but just pay attention and I think you'll be good. But this messes people up a little bit. So this is fourth root. Same concept applies, you split them up. So you have the fourth root of 6 over the fourth root of 5x. Okay. This is where people mess up, so please pay attention right now. This is the most critical part of this entire problem. How many do I have to have in order to bring 1 out for this problem? 4. How many 5s do I have? 1. How many x's do I have? 1. So how many do you need of each of those in order to bring 1 out? How many more do I need? 3, right? So this is where people get messed up, is they get used to just multiplying it by the same thing on the bottom, and they mess themselves up because that's not the case for this. The only reason why that worked on the last problem is because I needed 2 of something, and when I multiplied by another b to the power 5, how many b to the power 5s did I have? I had 1 here and 1 here. So I had 2, and I only needed 2 to bring 1 out. So that's why it worked here. For this problem right here, it's different because you need 4 of something. So what we're going to do is we're going to multiply it by the fourth root of, you told me I have 1 5, and I need 3 more in order to bring 1 out. So you are going to multiply it by 5 cubed. I have 1 5 here, and I have 3 5s here, so now I have 4 5s. Okay? I can't break it down any more than that.
One more time.
Okay? So you told me it's a fourth root. So I need to have 4 of something in order to bring 1 out. I only had 1 5. So I needed 3 more 5s. 5 cubed is like saying 5 times 5 times 5. So we now have 4 5s.
Yeah.
Same thing happens for our x. I have 1 x, but I need 4 of them. So how many more do I need? 3.
Oh, it's like the cube right there?
So we have to do x cubed.
Okay.
Now remember, when you have 4, you bring out 1. And what has to be on the top of this? The exact same thing as what I have on the bottom, because I technically want to multiply it by 1 so I don't change anything. So we have the 4th root of 5 cubed x cubed. Okay? What will you be left with on the bottom? Don't try to overthink it. You need 4 to bring out 1, correct? So bring out 1 5 and bring out 1x. That is what is left on the bottom. Okay? So for this, you now have 4 5s on the bottom. I've got 3 5s here, 1 5 here. I have 4 x's on the bottom. So I have 3 x's and 1 x. That's 4 x's. You have to have 4 of something to bring 1 out. So I had 4 x's. So you had 4 5s, so you brought out 1 5. You had 4 x's, so you bring out 1 x. Does that make sense? Okay? This is the part that is going to trip people up because they're going to forget that step, and that's why I really want you to be like very cognizant of the fact that you are going to remember to do that. Because you're going to, I can already tell you, this is where my honors kids had troubles before, was the fact that they got into the habit of doing it with a square root, and so they just assumed, okay, multiply by the same thing, and you can't do that, okay? So now the rest of it is the same exact thing, okay? This is the part that's going to be a little bit easy, because how many do you have to have something to bring 1 out for this problem? 4. Okay, 6. If you were to break that down, what would you have? 2 times 3. So I have 1 2, 1 3. How many 5s do I have?
3, 4, 4, 4.
How many?
3.
5 cubed. So I only have 3, okay? And I only have 3 x's, okay? So once we put these together, we have the 4th root of 6 times 5 cubed times x cubed, okay? You're going to have to type 6 times 5 cubed into your calculator to find out what that is, which is 750. So the 4th root of 750 x cubed over 5x. Why did I ask you how many you had of each of them? Okay? I went ahead and did that ahead of time, because if you would not have done that, you would have gotten 750. You would have had to check and see if that broke down, and to see if you have 4 of anything to bring 1 out. But I already know we don't. Why? This is 2 times 3, so I only have 1, 2, 1, 3. This is 5 times 5 times 5, so I only have 3 5s. And all of those numbers are prime numbers. So I don't have 4 of anything to bring anything out. So this is fully simplified version. Y'all hating life yet? This isn't even the hard part. Oh, great. Okay.
Well, we have a test today.
Still got a bit.
So Saturday? What you just said?
Yeah, I'm gonna have to sometime.
She just said, I heard Saturday.
I said it's still gonna be a bit.
Like a long time ago.
You've still got a while. Okay. Do we understand what I was talking about this part though? No? What don't you understand?
I'm not just that part.
Okay. So here, okay, so if you wanted, you can get to this point and you can take the long way out if you want to, and you can do a factor tree at 750, but to me that's stupid because we have already factored it out up here, right? This was us simplifying it, putting it as 1. So for here, if I look at this, this is 2 times 3 times 5 times 5 times 5. But it's a 4th root. So you have to have 4 of something to bring 1 out. But you don't have 4 of anything, you've got 1, 2, you have 1, 3, and you've got 3 5s. So you can't simplify anything. You can't bring anything outside of that radical. You get what I'm saying? So you have to leave everything underneath the radical. So 750 is not going to be able to break down, because when you do break it down, it's going to be 2 times 3 times 5 times 5 times 5. Got it? Okay. Does everybody else understand? Like, do you understand it? Yes, no, maybe so. I'm not a mind reader. They teach me the math in college. That's about it.
Yeah, I'm sorry.
Okay. All right. So, do you want me to go over this one?
Yes.
Okay. So we're going to do the same exact process. This is going to turn into the 5th root of 3 over the 5th root of 4y. 5th root tells you that you need to have 5 of something to bring 1 out. How many 4s do I have? 1. How many y's do I have? 1. So how many do I need of each of those to bring 1 out? 4. I need 4 more, right? So, I want an equal sign, I want a multiplication sign. So we're going to multiply this by the 5th root. I want 4 more, so I'm going to multiply it by 4 to the power 4, because now I have 1 4 and 4 4s gives you 5 4s. Good? And I want 4 more y's because I have 1 y, and I need 4 more y's, so we'll multiply that by y to the power 4. Now what I have on the bottom, I need to have on the top, because we want to multiply it by 1. So you will multiply it by the 5th root of 4 to the power 4, y to the power 4. Then what's going to happen? The bottom's the easiest part. The 5th root. How many did I have in order to bring 1 out? How many 4s do I have? 5. So we're going to bring out 1 4. How many y's do I have now? 5. So we're going to bring 1 out. Okay? On the top, this is a 5th root, and this is a 5th root, so you can combine them, right? So on the top, what do you have? You've got the 5th root of 3 times 4 to the power 4, y to the power 4. So this is the part we got confused on the last time, so make sure we're looking now. Do you see that we have 1 3? Okay? And we have 4 to the power 4. Okay?
So,
Let me ask you something. Okay? Because this is where it's going to get tricky. Okay? Is 4 a prime number?
No. Oh, no.
no.
Why not?
No.
Because a prime number says that you can only multiply 1 in itself to get that number. 1 times 4, yes, will give us 4, but we can also multiply 2 times 2. So our philosophy will not work here. What does that mean? I'm sorry, but we got to do a factor tree. I can show you another way that would be faster than factor tree,
You might just stress me out even more, so just.
but I don't know if it's going to confuse you. Okay?
Let's just stay with factor tree.
Do you want me to just explain what it is and then you can decide?
Yeah.
What's a prime number smaller than 4? 3, but can you make 3 become 4? No, think of another one. 2. Can you make 2 become 4?
Yeah.
2 to the power what? 2. So 4, this is actually, I'm going to do it off to the side so you can see what I'm doing really quick, just to like see if this is the route you want to take. So 2 to the power 2 gives you 4, right?
Yes.
This is to the power 4. Power to a power, so you add.
Subtract.
Power times so add.
Power to a power you multiply?
Power to a power you multiply.
So
Yes,
8,
sir.
To the power 8, okay?
yes,
Do I have 5 2s?
yes,
See what I did there?
yes,
Yes, no?
yes.
Or would you rather, see, we can do it this way, we can turn 4 to the power of 4 into this, which turns into this, which you can simplify.
You
Or-
can't see.
Oh, I'm sorry, baby. Or we can do the whole factors,
Alright,
right?
explain one more time.
So, 4. You have to have a prime number. So the only prime numbers under 4 is 2 and 3. There's no way you can make 3 become